for a few minutes. So volume. As we said, the definition of volume is the amount of space that an object takes up. And we're going to talk about a couple of ways that we measure volume. Because it depends on what we're measuring. It's the amount of space something takes up. So sometimes we have shapes, objects, that are what we call regular shaped objects. Things like this. So each of these objects here is a regularly shaped object. A sphere, rectangular, solid, rectangular prism, another rectangular prism. What do we call this? Cylinder. And so for these regularly shaped objects, we can very accurately calculate their volume using some formulas, using some math. And I know that these are probably formulas that you have seen before. Okay. And so formula for the volume of a rectangular prism, as you call it in math, or a rectangular solid, or a volume of a box. What's the formula, Evan? Length times width times height. Simple formula. We measure each side using a metric ruler. We multiply the length times width times the height. I grab an extra copy out of this drawer. So if we measure the sides of this object, okay, we multiply the length, 3 centimeters, okay, times the width, 2 centimeters, times the height, 1 centimeter, which obviously in this is a simple problem, gives us an answer of 6 cups of hummus.
6 centimeters cube. Cube.
Cube? Why cube?
You do it times 3.
Yes, so remember, what we do with our numbers, we do with our units. So 3 times 1 times 2 is 6. Centimeters times centimeters times centimeters is what? Centimeters cubed, sometimes called cubic centimeters. We also can calculate the volume of a cylinder. What's the formula, Sophia?
Diameter times height.
No. Bella? Nope. William?
Is it radius? No, pi times radius squared times height?
Correct. Pi times radius squared times height. Now when you look at these two formulas and you compare them to area, how do they relate to the formulas for area? Yeah, and so that should make sense, right? Because if we calculate the area of the circle by pi r squared and then multiply it by the height of this object, we're sort of taking a 2-dimensional surface and then making it a 3-dimensional surface by multiplying by height. Same thing with this shape. Okay, we can measure the area of the 2-dimensional side, and then if we multiply that by the height, we're sort of adding in that 3rd dimension. We're not going to go over the formula for a sphere, but there are formulas, or there are formulas for other shapes. These are the 2 that we're going to focus on, the 2 that you need to memorize. Okay. You guys know any other formulas for volume? No? Okay, that's good enough. All right, so if we look at the actual, how we would use it in this situation, what's the radius of this cylinder?
3.
No,
3.
Oh, what's the
Three.
radius?
three pieces of pita bread.
Centimeters.
The height is 8 centimeters. Hold on. So, we have radius, 3 centimeters squared, times the height, 8 centimeters, times pi. Break out your calculator, you're going to need it anyway in a few minutes. Raise your hand once you have an answer. Meg, what do you got?
226.8.
Veggie burgers?
Centimeters.
No?
I got
Evan?
2,260.8
Veggie burgers?
centimeters cubed.
We do, Kaden. If we do the math, 220.
I got 220.
So, we have to square our number first, our radius. So 3 centimeters squared is 9 centimeter. 3 centimeters squared is 9 cubic centimeters, or square centimeters. Times 8 centimeters, times pi. 226, we could round to 0.1 cubic centimeters.
On the calculator, there's a pi button, should we just press that?
Yeah, that's fine. It will give you just a slightly different answer,
Yeah.
because if you just do 3.14 versus the full 3.14156, whatever, that's fine, because we're always going to be rounding these answers, so those other digits of pi are not going to have an impact.
Oh, with the pi, it's 226.1946711.
Yeah.
Yeah, so it'll be slightly different. That's okay. You could use the pi button right up there. All right, so any questions about calculating volume of these two shapes? If we have the option, we always should measure the sides and calculate. It's a more accurate means of measuring volume than the next method, which we're going to talk about. So if we can do a math formula and measure our object, that's the method we want to use to find the volume of an object. We can also find the volume of liquids. Okay? And to find the volume of liquids, we use a special tool. Now, is this the tool we should use to find the volume of the liquid?
No.
Yes, no, kind of.
No. It's a little too small.
Not that it's too small.
Choose that.
It holds 100 milliliters, so it's not too small.
So if you have less than 100 milliliters.
This is what I should use.
Yeah, No. probably. If you have less than.
Who disagrees? And tell me why. So why do you disagree? Why do you say we should not use this, Luke?
Because use that one.
Why is this better?
Because, I don't know.
Right, Tom?
It's more precise.
Yes, it is. Why? What makes this, which we call a graduated cylinder, more precise than this beaker? Julia?
Because it's thinner and taller.
Excuse me?
Because it's like more thin and taller.
Yeah, but it's not so much the height of it. Okay? Yeah, it has more markings on it. It has smaller units of measurement. So if you look at this beaker, it has 20, 30, 40, 50, 60, 70, 80. That's all it has. So if you fill this up with some water, it's between 30 and 40. You're kind of guessing. Is it 34? Is it 38? This has markings for every single milliliter. This graduated cylinder is calibrated. It's meant for measuring the volume of a liquid. This is not. These are sort of estimates, rough measurements of the approximate volume. We don't ever use a beaker to find the volume of something. We use graduated cylinders. We have a variety of graduated cylinders. from larger 100 milliliter graduated cylinders, 50 milliliter graduated cylinders, 25. I have some 10 milliliter graduated cylinders. So all of these can be used to measure the volume of a liquid. And to do that, it's very simple. You pour the liquid that you want to measure into the graduated cylinder. Okay. And have you guys used graduated cylinders before?
No.
Some have. Okay. And what happens is when you pour water in, it forms a curve in the graduated cylinder. Because water is sort of sticky with the inside of the tube, with the glass, it forms a curve as you see here. It's called a meniscus. It's because of what property of water that we've sort of talked about before. Not surface tension. Not cohesion, because that's water molecules sticking together. When water molecules or any other molecules stick to another surface, it's not called cohesion, it's called adhesion. And so when we read a graduated cylinder, we always want to read the bottom of the meniscus. So for example, you look here at this graduated cylinder. A couple things we have to take into account. First of all, we see the markings. It's marked every 5 milliliters. What does this 10 go with? Does it go with this line? Right here?
No.
No, it goes to the solid line that goes all the way across. It's just written above it so it's more legible. So this is the 10 milliliter line, that's the 15 milliliter line, that's the 20 milliliter line. Okay? So what would you say is the volume of water that's shown? Oh, I guess it tells you. I shouldn't have said that. Let me ask you this question then, since it gives you that. What is each line worth in this graduated cylinder? Right? No. Because look at, will this make sense? If this is 5, is this 6, 7, 8, 9, 10? So not 10, it's not 1. Okay?
0.5 milliliters.
Does that make sense? So 5, 5.56, 6.57, 7.58, 8.59, 9.5, 10, yes. In this graduated cylinder, each line is worth a half of a milliliter. It will vary from graduated cylinder, graduated cylinder. This one, each line is worth 1 milliliter. This one, each line is worth also 1 milliliter. This one, there are tiny lines that are worth 0.5. Okay? So it depends on which graduated cylinder you're using. So we want to be careful of that. So yeah, this is 11.5. Here's 10. That's 11.5 milliliters of water. Now, if you have your choice, let's say I had 3 milliliters of water, or about 3 milliliters of water that I wanted to measure. Which graduated cylinder should I use? I have 3 milliliters of water. Which graduated cylinder should I choose? Kidding? This one? How come? The smallest one that my object will fit in. Because it gives us the most precise measurements.
And that one starts at 5.
Yeah, this one starts at 5, and this one starts at 10, so we wouldn't be able to measure volumes less than that. But yeah, we always want to choose the smallest graduated cylinder that's going to accommodate what we're trying to measure, because it's the most precise.
But isn't the like the one that the 25 one more precise because it has the 0.5?
So does this. This is 0.2.
Oh.
So this tiny 10 milliliter graduated cylinder has 5 markings between each whole milliliter, so each one's worth 0.2 rather than 0.5. So it's more precise. Okay. Now, when we want to measure the volume of gases, gases are sort of unique in terms of the property of matter. Gases expand to fill up basically whatever space you give them. Gases can be compressed quite easily. They expand easily. So often, a gas will expand to take up whatever volume it has of its container. So we often are not going to be measuring the volume of gas. The units that we typically use are milliliters, okay, and cubic centimeters. We won't often measure things that are in the liters in this class, but you could. And typically we don't use centiliters very often. We don't use that either. So the units we're typically going to use are milliliters or cubic centimeters. And an interesting thing to note is that 1 milliliter is the same as 1 cubic centimeter. They're the same volume. When do you think we use milliliters as our unit then?
Because it's the most precise measurement.
Well, it's not any more precise than cubic centimeters. They have the same precision.
When we're like measuring the volume of a liquid.
Yes, if we're measuring a liquid or using a liquid, we generally will use milliliters. When would we use cubic centimeters? Ivan?
Volume of like a solid object.
Yeah, if we're measuring 3 dimensions and then multiplying, then we would use cubic centimeters. Now what happens then if I have a shape like this? What formula, is there any formula I can use for this shape? So here?
Yes.
No. Not really. It's not a perfect cylinder. It has curves in it. It has one part narrower, one part thicker. It's got some indentations at the top. So I can't use the formula of a cylinder to measure the shape. It's not a sphere. It's not a rectangular solid. So it's irregular. So how can I measure the volume of this irregular?
Fill it with water.
There's no way to fill it
I mean, it's like
because it's a solid object, right? I can't put any water into it. David?
How can we make it into regular shapes?
I could try to like divide it up, but that's not going to be all that accurate.
Oh, I know. You can put it inside.
Oh,
You
no.
can melt it.
Luke,
You can weigh it and then fill that.
that would give me its mass, but not its volume.
You can melt it into like a liquid or something.
No?
And then you can shove it.
I want to keep my object the same. How about this screw here? Completely irregularly shaped.
Oh,
It still has volume, right? But it's not a cylinder or a sphere or any other regular shape. Any other ideas?
What if you put it in water, and the amount of water that came out was like the amount of milliliters?
That's exactly right. So we call that method that Evan just explained water displacement. Did you ever, you probably all taken a bath at some point in your life. Did you ever fill up the bathtub too high
Oh, no,
Yeah.
and then you get in and it goes like above the spout or goes, if it goes over the edge and spills out? If you submerge yourself in the bathtub, how much does the water level rise?
How much?
How much volume?
No, not how much you weigh.
How much
It rises the same as the volume of your body. When we submerge an object in water, the water level rises equivalent to its volume. And so we could use that principle to measure the volume of irregular objects, such as this screw or this weight. And the way that we do that is fairly simple. We put some water in a graduated cylinder. The level is not all that important. We record that volume. We then add our object. What's going to happen to the water level? It's going to rise. We record that number. And the difference between the two is the volume of that object. Okay. So that's how we use this process called water displacement to find the volume of an irregular object. Now, a couple things. You do have to be careful. You can't just put a tiny amount of water in. It has to be enough water that this will be submerged. You also can't put too much water in and the water level goes above the markings. So you have to have a sort of an in-between amount of water there, and that's how we measure it. Okay? So for example, if I put a 55 milliliters of water in a graduated cylinder, I add a small rock, I read the volume of water, it's now 63, I subtract, and that tells me the rock is volume is 8 milliliters, or 8 cubic centimeters. Any questions about that? All right, so that's all we need to know about volume, but we need some practice here calculating and measuring it over the next couple months. And so we're going to do that today with your homework. So you have some time to work on it.